Hey, my name is Trevor Smith. Welcome to Full Burn, where we kick some tires, light some fires, and interview awesome leaders across the space and defense industry. Today, I'm with Tadros, CTO of Redwire. Al, where are we today? You got me somewhere pretty unique.
Well, I thought we'd meet someplace that's very iconic in Silicon Valley. This is Stanford campus, probably one of the most beautiful campuses anywhere in the world, and we're at the main oval at Stanford campus. So straight up Palm Drive, and a lot of visitors and tourists stop in here. So
and we're going to do the full oval here.
Yeah.
Just so we get a good look at the scenery, because it is very beautiful here.
Yeah.
Can I turn left here?
Yeah, you can turn left. Sure.
Okay.
We might get a visit from the campus police.
Well, they already saw us earlier, so we'll just wave by. But yeah, it is beautiful here.
Yeah.
I see the mountains behind. Is this the main campus right here?
Yeah. This is kind of the center of the campus. The Graduate School of Business over on the left. Hoover Tower is on the left.
Oh, okay. That's what that. I was wondering what that is. It's beautiful.
Yeah. Hoover Institute is I mean, world famous, but Condoleezza Rice, I think, is the director there, and outstanding program and research that they do there, as well as other things. So we work with the Aerospace department here, and it's on a little ways further on campus.
I was going to ask you why we are on the Stanford campus. Why am I picking you up?
Yeah, why
on college campus?
Yeah. Well, I live about.
So if you look right here, this is the main campus with the tower.
Yeah. So this is the Hoover Tower there, but yeah, to the right is the main campus, and the church right there is iconic, kind of postcard Stanford.
Well, before you jump into why you're here, do you know what car we're in today?
I understand this is a Porsche 911.
It is a Porsche 911. All-wheel drive, super fun. And where are we going to take it today? Outside of campus, because we can't go very fast on campus.
Yeah. Well, we're going to take it up the Santa Cruz Mountains here up to Alice's, which is a restaurant on Skyline Boulevard up on top of the mountain at the ridge. So we're going to take it up and maybe have lunch up there, and then we're going to ride it around some windy roads.
Well, I think on the way, we get to drive through the very, very famous Sand Hill Road.
That's right.
So maybe give us a little background on the Sand Hill Road and why that's important.
Yeah. So, I mean, Silicon Valley kind of surrounds us. This was the founding of kind of the semiconductor industry, and then, you know, a lot of things, including tech industry, social media, now, you know, onto AI and other things. But a lot of it is driven by the investors that are here on Sand Hill Road. They sprouted up, and a lot of them based right on Sand Hill Road. Well,
before you had Zoom calls, you had to go.
That's right.
When you went to fundraise, you had to do the dog and pony show.
That's right.
And you had to come down traditionally down to Sand Hill Road and go knock on the door and meet people in person. So weird. Partially why I'm in town. But yeah, it's a really cool spot. I'm excited to drive through it. So we're on Stanford, and Redwire is doing something with Stanford. So maybe tell us a little bit about that before we get into your background.
Yeah. So first of all, I live about 3 miles away from Stanford campus. And you know, the proximity matters because I interact with the Aeroastro department for many years, including some professors working on artificial intelligence now. And we at Redwire are sponsoring a research project called Caesar, and it's really focused on AI-enabled autonomy. So part of what I do here...
Caesar, what's the meaning behind the name?
It's it's a consortium of aerospace engineering for autonomy.
Nothing to do with the Roman Empire?
No, although the professors, Simone D'Amico and Marco Pavone, are Italian, and I think that was the influence of picking Caesar. So so the acronym is Caesar, but it's really, it's focused on AI-enabled autonomy, and a great group of researchers, graduate-level researchers, looking at things like machine vision, rendezvous proximity operations, perception, even before you have a resolved image, meaning that you're looking at a space object with just, you know, pixels that you can't tell quite what it is, but with AI and training, it can start to characterize the blobs, things like that they're really advancing. So it's pretty exciting, and so that's.
Is Stanford the campus funding it, or how is it? How are you getting?
we are sponsoring that research. So
Redwire sponsoring.
Yeah, Redwire is sponsoring that research at Stanford. So there are a group of students and professors, and professors are Simone D'Amico and Mark Pavoni, who are kind of the founders of that the Caesar Institute. It's not so much profit from it, because the researchers will largely publish papers, but it's the ability to direct the research, to focus it on areas that we're most interested in, or we believe has the most business value. So the students, of course, are doing their PhDs or postdocs, and they want to create new knowledge and advance the cutting edge. But yeah, we take those algorithms or concepts, and we transition them into benchtop breadboards, demonstrations, and then ultimately into flight systems. So flight software that flies.
I know that you guys are 3 years in. Is there an example already that you've taken out of campus and across the Kármán line?
Not yet, but we have these sprints that we deploy on breadboards on the ground, and then we have labs where we simulate space environments. So those are the kind of things that we're doing. Now we are flying some pretty amazing missions, and I could talk about some of those that will benefit in the future from these technologies, and that's what motivates us. Is okay, we have these missions, the government wants to do certain things.
Yeah, give us a couple of examples of your more exciting, one of your favorites.
Well, a couple of programs that are public is the Tetra program, which is a Space Force mission to demonstrate rendezvous proximity operations, docking, and refueling in geostationary orbit. So this has been a long time in coming, and there's been a lot of different demonstrations. So this isn't like out of the blue. But that is a mission that contains a lot of different technologies, and ultimately it's to enable refueling of spacecraft in geostationary orbit.
Yeah. So just for maybe my mom listening. Rendezvous proximity operations, docking, RPOD. Yeah. What does that do for the DoD and commercial customers who can utilize that type of mission? Right. If you can refuel, if you can life extend, what does that do?
So if you can imagine, example of airplanes flying from point A to point B, from LA to New York. Right now, all our satellites are basically built, fueled, and launched with
one-time use.
One time. And when it runs out of fuel, it's done. So we design them to carry enough fuel to complete their mission, and that's it. But the possibility of refueling a satellite and being able to maneuver it, or take up less fuel because you can refuel it and take up more payload or more capability, that is really enticing. And then there's, of course, war fighting, where you want to be able to maneuver, evade, that requires fuel also. So I think most people have seen what in flight refueling looks like for the military.
Right.
So a jet.
You've seen those airplanes that do mid-air refuel.
That's right.
Super
so a jet will approach a tanker, and attach and refuel. So that really doesn't exist in space yet. The government wants to do that, and that's what we're demonstrating with the Tetra program. So there's a lot of technologies that go into being able to do that, including having two satellites approach each other safely and then dock
moving
each other.
Quite faster than your typical air tanker refuel.
Yeah. Now it doesn't look like it, right? When an astronaut is in the space station and they're floating around, it looks but they're very peaceful and zero gravity or microgravity. But in reality, they're traveling at 17,000 miles an hour. They're traveling very fast, but relative to each other, they're traveling only at meters per second, or centimeters of a second, and then ultimately docking and connecting. And that is a whole set of technologies that it just hasn't existed, except for kind of exquisite systems. Vehicles docking to the space station.
Quite the expensive choreographed dance.
It is, and that's been the hurdle, is the expense, and the industry needs to get it to a point where it's just another capability. So it shouldn't be like, oh, we can't afford doing that, but when do we need it, and let's put it on.
I mean, I can't imagine, paying for a brand new F-35, going on one mission and be like, oh, it's done.
It's done.
It's done.
Get a new one.
Which is like, we've got assets in GEO that are billion-dollar birds, or satellites, right?
Yeah.
Way more expensive than an F-35.
Yeah.
And we are one-time use.
Yeah.
Their flight is a little longer than an F-35, but
they are.
Yeah.
But the decisions made as to whether to relocate them or to move them or fire thrusters is really driven by, hey, it's a consumable. It's limited amount of fuel. Should we do it or not? And it really shouldn't. It should be about the mission. It should be hey, we need to do this and this, and we'll refuel it if we get to deplete the fuel. So that's a whole, and we've been looking at this. The industry has been looking at this.
Are these some of the redwood trees?
Yeah.
Holy cow, that thing's big.
We're this is Portola Road, and this will go all the way up to Skyline, and there are redwood trees all along the coast.
That thing was as wide as the car.
Yeah, you'll see some beautiful trees. Provide a lot of shade.
Man, that was a big tree.
They grow like this because they they capture the fog. It doesn't rain anymore here along the coast. It just the trees get the moisture from the fog, which you missed by coming this late in the morning. Yeah, you come at night, or it cools off quickly with fog rolling in. Yeah, this is a beautiful road, so hopefully you enjoy this. It gets windy, a few hairpin turns.
Yeah, we're going to find out in a minute about that. So let's hear a little bit about who Al Tadros is. Hey, there we go.
Focus.
I want to warm you up a little bit.
It's got pep.
That it does.
So first of all, have been living here 35 years now, so
you must like it.
I'm a Californian, by default here, I think. So most of my life has been here in Silicon Valley, but before that, I grew up in Southern Illinois, a small town in Southern Illinois, and then I went to school in Boston at MIT. So I spent 5 years in Boston before moving out here.
Okay.
So I've seen a little bit of the Midwest, a little bit of the East Coast, and then spent most of my life here and all my career.
So you went to school, and what was your major?
I was an aerospace engineer. So Aero-Astro, course 16 for the techies. So at MIT everything is numbered, classes numbered, departments are numbered. So course 16. So I did Aero-Astro undergrad, and then I stayed for a master's, and then I got into my Honda Civic, two-door hatchback.
There you go.
Drove across the country. Made it over the Rockies and rolled downhill into California, and there I have been. But I started a company. The company was called Ford Aerospace.
So I saw that on your LinkedIn. I said,
yes.
I said, Al, like the same Ford is like Mustang Ford?
Yeah.
I didn't know they had a space division or an aerospace division.
Yeah. So up until about 91, 92, they had a Ford Aerospace, and it had evolved from different acquisitions. I think Philco, the original kind of RF radio kind of company, was the start of that Palo Alto location, and then it became Philco Ford and Ford Aeronautics. So it came under different names, but started in the 50s there in Palo Alto.
Wow.
Kind of out of radar and RF equipment, and became a space company. And interesting trivia on it, as Silicon Valley transistors started to become a thing, and Philco turned down the opportunity to be one of the early adopters and manufacturers of transistors, and said, no, space is where the business is, space is where we're going to focus. And it became Ford Aerospace rather than the next Intel or National Semiconductor.
I think people would hear, they know Intel, and I'm not sure they've heard of Ford Aerospace before.
No, nobody has.
Right? Maybe they should have made some silicon chips.
Maybe somebody should have thought about that. But it resides right there in Palo Alto in the middle of Silicon Valley, and built amazing satellites over the last 30 years. Now it's known as Maxar. So it went from Ford Aerospace. L'Oreal bought it in the early 90s, And just like a lot of other industries, there's a lot of M&A and transition and scaling. And now, it's known as Maxar Space Systems.
Big company.
Yeah, and great company, great experience, great technologies and people there. So really enjoyed working there for a number of years.
So Maxar, and then what came after Maxar?
Yeah, so 5 years ago, actually, I just passed my 5-year anniversary at Redwire. I joined a company that had just coined the name Redwire, and it was actually a private equity firm that had a vision of growing a pure space company by acquiring, integrating, and scaling multiple, small space companies. So we have, over the last 5 years, we've acquired 11 companies. We just closed on the most recent one, Edge Autonomy, which is actually not a space company. I'll come back to that. But, but the acquisition of these companies, and they're not startups so much as they had products, were into revenue, and we're looking to exit so they can scale, transition the management team and be able to scale. So this is kind of we're approaching the summit here.
But it's actually, this is good because you said there's a good spot up here for lunch.
Yeah, right there, Alice's
restaurant.
There you go.
We're going to break for lunch.
All right.
And then we'll talk more about Redwire. And then I think Al's going to get in the hot seat.
Awesome.
Or the driver's seat. Yeah. All right. We'll catch you in a little bit.
All right.
We're back. I'm getting Al in the hot seat. We just had lunch at Alice's restaurant. There will be pictures of horses. We had some horses, some cowgirls come up for lunch. There's motorcycles here, all kinds of fun stuff. But I didn't expect horses and cowgirls to be at lunch 5 minutes out of Silicon Valley.
Literally, we had 3 horses riding into the lunch area.
Yeah, that's go for it. Give it a little punch if you want. See what the Porsche's got. There we go.
Stay away from redlining.
Got the Boxster engine in this. Do you know what the Boxster engine?
No.
So the cylinders, instead of like a V8, it's a flat 6. So you have the pistons perpendicular or 180 degrees. Yeah. Makes for a unique sound that all the Porsche enthusiasts,
Nice.
love. Well, let's jump into Redwire.
Sure.
So one of the things we were talking about earlier was Golden Dome.
Yeah.
And how does Redwire look at Golden Dome as much as you know about Golden Dome? Because it changes by the minute, it seems like. So how does Redwire prepare for what's coming down the pipeline, and maybe start with what is coming down the pipeline, if you know?
Right. So first of all, Golden Dome, for those who aren't aware, it's really an architecture, a full architecture, not just one thing or one capability. And the architecture is to defend against both, ballistic missiles, hypersonic missiles, glide vehicles, etc. The threats of the next generation, which are dramatically different than the Cold War. So Golden Dome is looking at how do you detect, track, defeat those kind of missiles. So space is going to be an important part of that. And the executive order includes space-based interceptors. So anti-missile missiles that would be based in space and be deployed from space in order to thwart any enemy that's trying to attack us with hypersonic vehicles or missiles. So that's includes a whole slew of things, and I'll share a little bit about what Redwire is interested in bringing to the game there. First of all, we have...
You're having fun, by the way.
I know.
This is sporty.
This is... so I think it could do a little over 1 G of cornering, so I'm going to test that out.
Yeah.
We talked earlier about Elon Musk's experience on this road with a McLaren.
Oh, is this the road?
Yeah.
I started watching the video. I didn't know it was this road. So this is the road that he famously crashes his F1 from McLaren.
That's right.
Without insurance.
He admits it. He talks about it, and he says it started by him saying, "Watch this," and the next thing is they're spun out on.
Well, he didn't have all-wheel drive. You have all-wheel drive.
That's right.
It's a lot safer.
True. There's probably a lot more technologies now than 20 years ago when he spun out the McLaren. So one of the things that that we have the pleasure of doing is working with a company called Crossbow in building rocket bodies and for their solid rocket motors. And those rocket bodies now have flown 3 times and is going to fly again. And these are suborbital, but full-on, solid rocket motors, and are perfectly suited for things like space-based interceptors. So that's one of the capabilities that we're applying to Golden Dome, is our relationship with Crossbow, or building rocket bodies for these kind of stored and deployed missiles. And solid rocket motors are something that have been used in space for many years. They were oftentimes used for apogee kick motors or orbit raising, moving a satellite from one position to another.
That's some propulsion right there.
All right. This is addictive.
See, it's kind of hard to have a conversation.
Yes, it is. Yeah, it is. I'm not sure I'm going to get into Mini Cooper after this.
Oh, there you go.
So, all right. We're going to do a U-turn here in a second, and then make our way. Let me see. This is probably a good spot. Let me try not to...
easy on the lip. That's actually pretty high. See
if
you can
that is.
get another one.
Let me get a finished surface to do that.
Try not to have any debris on the front bumper here. Lots of debris in space. We're trying to avoid that here.
Trying to avoid road debris. So that's one of the things, is space-based interceptors. And that's really important because from space, you can actually approach an incoming missile at with high velocity already, and be able to. Oh, here's a nice scenic spot that we can do a U-turn on.
So you got space-based interceptors. What other technology is Golden Dome looking at to build out this capability?
Yeah. So being able to
yeah, you're good.
Being able to detect, monitor, and track hypersonic vehicles, and that's something that you can do from space. So being able to deploy missile warning, missile tracking payloads, and one of the capabilities that we've been developing with the U.S. government is vehicles for very low Earth orbit. And by very low Earth orbit, you can think of it, for those who are familiar, 250 kilometer, 200 kilometer type of altitudes, where you're actually touching the atmosphere, and the atmosphere at that point is atomic oxygen and atomic nitrogen.
Which is a difficult environment by itself to survive in.
Hugely. Think of something extremely reactive or extremely corrosive, so we're going to try not to... We give wide berths to bikers here in California. So
there we go. So you got this VLEO vehicle.
So VLEO, and we have a product called SabreSat, and that is an exciting platform because it's much closer to the Earth, where you can use sensors that can detect and track hypersonic vehicles, as an example.
Is the latency like one of the bigger advantages for being in VLEO versus LEO, MEO, or GEO?
So the latency is a concern for interceptors. I'll say latency for interceptors, the distance to intercept. So if you're flying at 250 kilometers versus 500 or 600 kilometers, and you have space-based interceptors at that low altitude, you're that much closer to the hypersonic vehicle, and that is one consideration for VLEO platforms. It's also the optics that are needed. the optics that are needed as you get closer to the Earth, the aperture, the size, the optics that are needed are smaller, or you could get better resolution, better performance because you're closer. So those kind of advantages come with a VLEO platform. Those are two of the areas. There's also just detecting and monitoring what the adversaries are doing, and that can also be done advantageously from low Earth orbit. So there's a number of things that are done from that. And then there's just communicating and connecting to the different elements, even if you have airborne vehicles.
Like a relay point. Like a Wi-Fi hotspot.
That's right.
Yeah.
So from space, you can actually see very large areas of regard. So a single satellite can see hundreds of kilometers, whereas for UAVs, or small drones, you might only see tens of kilometers of distance. So there's an advantage there that space can bring to the warfighter.
We were talking about autonomy, and why is autonomy important for space specifically?
Yeah. So there is a tremendous amount of information being collected, and there's now a proliferation of vehicles, both in space and in air and sea and ground, meaning that where you might have had, a few or dozens of vehicles, in a region, a battle area, now you might have hundreds or thousands, and they're talking about operating in that kind of overwhelming dominance.
Well, you can't have a one-to-one human-to-drone ratio.
That's right.
Swarm technology.
Even if you tried, just communicating between operators would consume everybody's attention span.
Yeah.
Hell, I'm driving one car and I'm like trying to focus while talking.
It's way easier sitting on this side.
This is super fun though. Autonomy is critical because you have an overall objective, a mission objective, and you're trying to accomplish that while, very dynamic adversary or, evolving battle or whatever the mission is. So having the ability to set high-level objectives and have the platforms optimized, even if they're degraded, low on power, low on fuel or whatever, decide how can they best contribute to the mission. That kind of capability is a real game changer and discriminator, meaning that if we can do that better than our adversaries, we will have an advantage. So that's really the objective there.
So we brought up geosynchronous orbit, rendezvous, and proximity ops or proximity operations. Why is rendezvous and proximity ops so important in that geo orbit environment to Redwire?
Yeah.
Or to your customer?
Well, first of all, there already are existing and very important assets in geo for the government. So that is one reason. But geo orbit allows you to have access
constant in one spot.
That's right, with one orbit, and it's simple, relatively simple.
You should keep two hands on the wheel.
I know. This is it's good that I'm talking because otherwise I'd be even more tempted to take these turns.
RPO and geo.
So bad idea to have me drive while talking about RPO and geo. I think this is the first time ever someone's driving a 911 while talking about RPO. So so in geo you have about 300 satellites, and that there's orbital slots in geo, and that's basically what determines the amount of satellites and the coordination and location of satellites. But those 300 satellites, you can drift from one to another fairly easily. So if you have a refueling system that can access all 300, access all of your satellites, that's a huge advantage. And
because those typically are more expensive satellites than what you would see in low Earth orbit.
That's right. Yeah. It costs more to get them there. They typically can be larger. They might have larger apertures because they're operating from a farther distance. There's a number of, and you typically, it's a national asset, meaning it's over a single area, region, or nation, and the suspension and control of a car. I mean, way out surpass. Actually, that's one of the beauties of Silicon Valley is they have a lot of self-driving vehicles and electric vehicles that.
I thought you were about to segue that into space.
But that is, I mean, it surpasses what we do in space and space vehicles, and it shouldn't be. We should be deploying some of the best technologies in space. Like I want to drive right or fast around this corner. There's so much electronics in here controlling the stability of the car that it'll keep me from spinning out on a corner like this. Anyway, satellites need to get, up the technology adoption curve, and a lot of it isn't that the technologies don't exist. It's that is just traditionally has not been the mode of operation in space. We oftentimes will want the operator in the loop if there's an anomaly. There's a Cybertruck.
Hey.
Anyway, rendezvous proximity operations in GEO is potentially a big game changer because you can refuel a lot of satellites with relatively little difficulty.
So, speaking of defense, you guys made a recent acquisition that was sort of surprising to the space industry and what we all thought was maybe outside the strike zone. You bought a drone company, not necessarily for space, but for terrestrial applications. Can you talk a little bit about that?
Sure.
After we get through this if your sons and daughter is listening, he's going to buy one of these. I think he's got a grin on his face the whole time.
We were talking over lunch. Yeah, my kids are more interested in the 9/11 than the space topic. So we're whatever it takes to engage the youth, the next generation.
It's such a sacrifice today.
So Edge Autonomy, awesome company, awesome technologies, been in business for over 20 years and has a couple platforms that the Penguin and the Stalker that they build for defense and government and other users that we're really happy. We just closed a couple of months ago on that acquisition. I going to a conference next week in London, DSEI, where they're presenting. They're out there at all the shows. So if you're at a defense and space company, you'll probably see some reference to them.
Did I see you on the World Satellite Business Week? Are you speaking there?
I'm not. I don't think I'm speaking there. I'm not speaking there, but I will be at. So right after London is the DSEI is World Satellite Business Week in Paris. So
I'll be there doing a couple more full burn recordings in a different car. Maybe we could have part 2 in Paris.
Awesome. Hey, trivia question. Do you know how 9/11 got its 9/11?
Oh man, no, I do not. And all my car buddies are gonna hate me for this. So I don't know. Tell me.
All right. Well,
I know they number all the cars.
Yeah.
And so they have so many models just for the 911. I think it's like 32 models, but they do like 991 or 911.1 or .2. But tell me how.
So it was the 901 project by Porsche. And when they came out with that nomenclature, Renault, I think it was Renault that said, hey, that's our trademark. It's 3 numbers with a 0 in the middle.
There we go.
And Porsche said, okay, we'll make it the 911 instead of the 901. So it ended up starting out like that, and then the models came out.
And I think this is their best-selling car, or they're most known for the 911.
So good on.
Oh, there's a Ferrari. Hey, how's it going?
Everybody enjoys this road.
So how does Redwire look at acquisition just in general? Right. So you acquired Edge Autonomy, but that was sort of outside space. But you've acquired a bunch of other space companies. That's kind of how you were built. You were built off private equity from AE Industrial.
Right.
Right? Yeah.
So, first of all, just, this is all public, and we've stated that our intention is to grow. We're going to do this right turn.
Yeah, take it wide.
Yep.
There you go.
I'm going to try not to
you're good.
run over the road. Okay.
Oh, we got a little scratch. That's all right.
So we look for, we're not looking at startups. We're not looking at early stage, companies. We really look for companies that have, established product in customers' hands, revenue and profitability, quite frankly. And the challenge they have is to scale, and either scale number of products or depth, volume, and those are really kind of the starting point. And there's a number of companies in that category, but yeah, it's not necessarily small startups that we're looking at. We are, as
you said earlier, I think they've crossed that valley of death. They've got over the hurdle. They have real customers.
Yeah.
Right. Is that the sort of mile marker that you're looking for?
That's right. Some proof of delivering products to customers, demand by customers, and so forth. Now, initially it was focused on space, and we grew substantially to about 700, 800 people in that direction, and we were able to scale in that. But the opportunity to grow in the broader defense, aerospace and defense, came about with Edge Autonomy, and that's the direction that we decided to go in. So yeah, going forward, I think we're going to continue.
They got the Porsche wave.
That's right.
She waved at you.
We're going to continue growing in kind of aerospace and defense, where there's synergies, and Edge Autonomy has a lot of similar focus in technology-driven capabilities, defense applications, and quite frankly, a lot of parallels to what we do in space, but in the air platforms.
So one of the questions, and we've talked a bit about Redwire, but I'd like to hear like the origin. So what was it, one, maybe walk us through in the next 2 minutes, what was it like, how you got recruited to Redwire? And then talk to us about the transition from private to public.
Okay.
Because you got SPAC'd. You were one of the space SPACs.
Yeah.
So what was day one getting recruited in and then going public?
The private equity firm, of which our current CEO was an operating partner at Aero Equity, got my name through some of the industry contacts and reached out to me. And as I was mentioning during lunch, I initially said, "No, I'm good." And then a couple other calls, and I finally asked, so what is it that you're trying to do? Because I understood that they weren't a startup; they literally were. So he explained, and part of it appealed to me, and the part was that I really hadn't worked. The years that I was at Maxar, I hadn't worked on the acquisition and scaling of a company. The business in Palo Alto was largely, roughly the same size, fluctuating over time. So that appealed to me, and as I learned more and more, and I understood the types of companies they were going to acquire and scale, and it's, I've been in the industry a long time. I actually knew a lot of the people and the companies. It started to appeal a lot more to me, and ultimately, I really wanted to be part of that vision. So it's been an exciting ride, and quite frankly, between that and then, as you pointed out, we went public like within a couple months of me joining. And again, we were a small.
Hey, let's start a startup, and then we're going to go public in less than 12 months.
That's right.
How quick was that?
Right. It was within a few months. We started discussing it internally, and then it was like within 6 months we were going public. Is a real experience, and especially. On a fast pace. What did
you guys do to celebrate the SPAC day? What did that look like?
Well, we had a number of people.
Do some fun?
Yeah. Well, we went to the Big Apple, went to New York City, and we rang the bell.
Did you get to ring the bell?
Yeah. Okay, this is where I was going to drop you in.
Oh, this is the Tesla
Global Engineering Headquarters.
Oh.
Right here.
What a treat.
And I'm going to...
Oh, that's a cool entrance.
Yeah. I'm going to...
That's cool.
Let's see. In Tesla, a lot of people think of it as a car company.
There's a lot of bicycles up front.
There are a lot of bikes in front. That's Palo Alto in general. A lot of e-bikes, some off-road bikes. But,
cool.
Optimus, people should watch out for Optimus and the AI aspects of Tesla. Tesla's an amazing company, I think, and quite frankly, it's, another, they have a lot of buildings here doing a lot of things, but having the global headquarters for engineering here is, I think, pretty special.
That is cool.
So they're here. What
is the fastest you have ever been in a land vehicle? Was it today?
No, actually, I visited Germany and got a chance to drive the Autobahn.
Oh, nice.
And, if you weren't going 90, 100, you were being passed.
Yeah. So if you had a blank check.
Yeah.
What vehicle, ocean to orbit, doesn't have to be a car.
Yes.
What vehicle would you go get? Blank check.
Blank check? My kids will kill me if I don't say 911.
All right, so 911, yes. We'll go ahead and give you another one.
But I am bringing you to the lot
McLaren dealership
where I am going to be picking up my car with you.
What are you getting a McLaren?
This is a step up.
So that's the 750 I was talking about.
I'm telling you, this is. I live about half mile from here.
Speaking of blank checks, the dealership's right here, Al.
That's what my kids point out is. This is what we had to drive by.
Oh, we're nice! Look at all those beautiful McLarens.
All right, we're gonna.
Oh yeah, you can totally swing through here. Look at this.
In a McLaren shop, here's.
I'm in heaven, man. Look at all these cars.
And seeing these just on your commute around.
Oh, if that's not motivation on your drive into work, I don't know what would be. At least for me.
Yeah.
So what vehicle would you get?
Well.
Besides the Porsche 911?
It actually would be heading towards the Porsche.
Okay.
So,
is there anybody that you would recommend to come on the pod that might enjoy this moving podcast studio?
Yeah, good question. I mean, there's so many amazing people. One name that comes to mind, I don't know if you know the founder of Millennium Space, Stan Dubin.
I don't know Stan, no.
Yeah, Stan's in LA. I just got a chance to see him. Now he sold it to Boeing 6 years ago, 6 years ago, Millennium Space, and it's part of Boeing. But he's done and seen multiple startups and he's done and seen a lot.
Sounds like a good interview.
Yeah.
I'll be in LA soon.
Stan Dubin is.
I'll have to good if you don't mind. Share his contact information.
That's yeah. I think he'd have a lot of fun. I don't know if he'd be willing to do it, but I think it'd be a good combo. So I'm gonna jump out over here.
Okay.
I've had a great time. I appreciate the conversation at lunch too, which wasn't recorded, I don't think.
No.
We took pictures.
With the horses.
We were like tourists around here.
This was the longest recording I've ever had.
Okay.
And the best scenery. We had lunch, hung out. We talked a lot of space. Al, I thoroughly enjoyed it, man.
Yeah.
It's been a good one.
Awesome. Thanks, Trevor.
Thanks for coming on.
Yeah.
Thanks for watching, everybody. It's been Full Burn. We'll catch you next time.